Imagine designing a globally distributed cloud financial system. It spans continents, processes millions of transactions a second, and interfaces with dozens of legacy databases. Immediately, your security expert demands strict AES 256 encryption protocols and zero-trust access across the network. But your CFO looks at the exact same system and only asks about server deployment costs. Meanwhile, the chief regulatory officer needs proof that user data stays geographically isolated to comply with local privacy laws. In systems engineering, these competing demands are called stakeholder concerns. If you try to document all of these distinct concerns on a single traditional architectural drawing, the system breaks down. You get a blueprint covered in hundreds of conflicting annotations and intersecting lines. It becomes a dense, unreadable mess. Large-scale systems rarely fail because of bad code. They fail because a single diagram cannot capture competing realities without collapsing into chaotic miscommunication. This exact crisis is what the ISO IEC IEEE 42010 standard was built to solve. It is the international benchmark for software and systems engineering architecture. The 2022 update to this standard enforces a strict philosophical rule to survive modern complexity. Architects must explicitly separate the rules used to design a system from the actual results of that design. This split moves design away from individual preference. By standardizing the framing rules into reusable templates, an organization ensures its architecture stays consistent and manageable, even as the system scales across hundreds of contributors. This dichotomy is crucial. The architecture viewpoint is a strict rulebook framing a problem, dictating modeling languages and compliance matrices, not actual hardware. The second half is the architecture view, the concrete blueprint generated when applying these viewpoint rules to a real-world project. The view contains the tangible details, the specific AWS servers situated in Frankfurt, and the actual SHA-3 hashed data pipelines unique to the system you are building right now. Because viewpoints are abstract rulebooks, they are highly reusable assets. Major international frameworks, like the NATO Architecture Framework, predefine these viewpoints so they can be reused across thousands of distinct defense and infrastructure projects. Viewpoints are the reusable factory molds. Views are the highly specific, unique products cast from them. Modern agile environments require speed, and the 2022 standard adapted by officially killing the concept of the rigid, monolithic architectural model. A single view is no longer a massive, unbreakable document. Instead, the standard introduced view components. Views are now modular assemblies made up of separable parts. These components can be model-based, like strict UML sequence diagrams governed by specific languages, but they can also be non-model-based. You can include text spreadsheets, recorded interview transcripts, or FDA compliance checklists directly. The ultimate advantage of this modularity is component sharing. A single access control component can be simultaneously plugged into a security view, a functional view, and a deployment view. When an architect updates that specific component, every single view that shares it updates automatically. This structure establishes a single source of truth. It eliminates the fatal mismatch errors that used to plague complex project documentation when systems evolved faster than the paperwork. The 2022 standard keeps these modular components active through 3 specific view methods. First is the construct method. Architects use specific design heuristics and patterns to logically build and connect valid components from scratch, ensuring the syntax is mathematically correct. Next is the interpret method. This is the critical translation step. It applies semantic legends and visual filters, so both a lead engineer and a non-technical CEO can read the exact same diagram and extract the information they need without confusion. Finally, the analyze method subjects the generated views to quantitative evaluations, like queuing network simulations, to prove the system won't bottleneck before a single line of software is actually coded. These 3 view methods turn static diagrams into a verifiable active engineering lifecycle. By mandating the documentation of specific design methods, modeling languages, and stakeholder concerns, the standard forces hidden design logic out into the open. It transforms what was once personal intuition into a formal, traceable enterprise asset. By definitively separating how we frame a problem from how we solve it, organizations can build out the world's most complex systems, from global software platforms to massive Internet of Things networks. It ensures that no matter how enormous a system grows, every single component remains strictly governed, traceable, and perfectly aligned with a unified goal.